Section 13.6 is the tangent function. I can graph the tangent function. Big ideas. The tangent function has infinitely many points of discontinuity with a vertical asymptote at each point. Its range is all real numbers. Its period is pi. Discontinuity, guys, just means that there's a break in it. It's not a continuous line. Something happens. There's a hole. There's an asymptote. We can't have a value there. It means there's some value not in our domain. Suppose y equals a tangent of b times theta, with b greater than 0 and theta in radians. Then pi over b is the period of the function. One cycle occurs on the interval from negative pi over 2b to pi over 2b, and there are vertical asymptotes at each end of the cycle. So all we're saying here, guys, is that if we have pi over b, we're going to center it, okay, there. So half of it goes to the left, half of it goes to the right, half to the negative, half to the positive. And it's pi over b instead of 2 pi divided by b for the period, because there are, its period is just pi. So we don't take 2 pi divided by b because the entire period isn't 2 pi like it was with sine and cosine. It's just pi. So take note here. Tangent of an angle on page 868. Suppose the terminal side of an angle theta in standard position intersects the unit circle at the point x, y. Then the ratio y over x is the tangent of theta, denoted tangent theta. Y over x, guys, tangent is sine over cosine. I'll fix that here. I don't know which one is going to be easier for you to remember. If you're going to remember tangent is y over x or sine over cosine. Sine over cosine is going to come in handy later. So as long as you can remember that x is cosine and our y is our sine value, then tangent is y over x or sine over cosine. There's a graph on the bottom of page 869 that shows one cycle of the tangent function. So it looks very different than our sines and cosines. That's because here it's the ratio of the two. So as sine changes, so does cosine, and so does the ratio between them. And it's going to be very different than that circle because it's not just a point on the circle. It's the ratio of the two values. So finding tangents geometrically. What is the value of each expression? Do not use a calculator. So I am going to get us a circle. To start with, maybe. Okay. And pi is pi over 1, so one line to split it up. So we have 180 degrees here, which is the same as pi. 0. It also loops around to be 2 pi. So at pi, I'm going to draw an imaginary axis here. I didn't actually split my circle. We could have, but I'm looking for this point right here. I'm looking for where our circle intersects at pi radians, which means I've gone all the way to here. So the coordinates at this point, x is -1, y is 0. Tangent of pi is going to be y over x, or sine over cosine. Y is 0 over -1, which means we get 0. So tangent of pi is going to be 0. Tangent of 5 pi over 6 let me clear some of this out here. We're going to split our into 6 pieces, each pi. So each half of our circle into 6 pieces. I've already drawn in one line here. To split it, I need 6 lines. So I'm going to split it 2, up and down. I'm going to try that again. Now, I need 6 total, which means I'm going to split these into thirds to get my 6. I'm going to try and go evenly or pretty close. So again, I've split my circle into 6 pieces because of the 6 here. So I drew 6 lines to separate it, and each pi, which means just my top half and my bottom half, or each 1 pi, are split into 6 pieces. So right now I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. And again, we can simplify some of those down. 3 over 6, for example, is just pi over 2. 2 over 6 is pi over 3. And 4 over 6 is 2 pi over 3. 6 pi over 6 is just pi. So we can simplify that as we go. Remember, here is 0. But that's not the most important part. The most important part is that we're looking for negative 5 pi over 6. So I'm going to have the same idea. I have them cut into my sixths, but I'm going to go negative 5 pi over 6. So negative pi over 6 from 0. Clockwise is negative. Negative 2 pi over 6. Negative 3 pi over 6. Negative 4 pi over 6. Negative 5 pi over 6. So this point right here is the one that I want. We always draw our line to make our triangle to the x-axis. Not a very straight line there, sorry. Here, I mentioned this to one of the classes. I don't know if I did the other one. Something to kind of think about. Pi over 4 always deals with 45, 45, 90. So whether it's pi over 4, 3 pi over 4, or 7 pi over 4, it doesn't matter. If it's over 4, it's always going to be a 45, 45, 90. If it's pi over 6 or pi over 3, it's going to be a 30, 60, 90. So I know for sure that this is a 30, 60, 90 triangle. I just need to decide which side's my long side and which side's my short side. So by looking at my picture here, I can tell that this is my short side and this is my long side. But if I wasn't sure, think about how we split this up. We split it into sixths, right? Which is smaller than a third, which means this is pi over 6 is 30 degrees. So opposite of our 30 degrees is half. Okay. Now I'm going to check my signs. Because I'm in the third quadrant, these are both going to be negative. So the coordinate of my point there is negative square root of 3 over 2. That's my x, how far over. And negative 1/2, my y, how far down. So tangent of negative 5 pi over 6 is y over x. And now we're going to reduce this and simplify. So 2 negatives make a positive. I'm going to have 1/2 times the reciprocal, 2 over square root of 3. To get rid of division, we multiply by the reciprocal just like we did in chapter 8. And like we did with our radical expressions, we rationalize them. Multiply by square root of 3. We never want to leave a square root in the denominator. So it's going to be square root of 3 over 3. And that is what tangent of negative 5 pi over 6 equals. Seems like a lot of stuff there, guys. But you're going to get a lot more comfortable with these the more you deal with them. And we're not going to have a ton of time, obviously, this late in the year to get into a lot of the trig stuff. But for those of you that take college algebra and or calculus or a math in college, you'll dive further into this trig and get more comfortable with those. Now, what's the value of each expression? Do not use a calculator. So, I'm going to take my circle and if I really want to, I can go ahead and split this up for my first one. Pi over 2 okay. Pi over 2 is right here. 1 pi over 2, 0 pi, halfway. Tangent here, this point. And the coordinates of that point are going to be 0, 1. Remember, we have y over x. Can we divide by 0? No, we can't. So, tangent of pi over 2 is going to be undefined. There's no value there. Can't do it, no solution, undefined. Okay, I'm going to go ahead and get rid of this line and split it up into thirds. About here and about there. Not perfect, but at least kind of get the idea. I want tangent of 2 pi over 3. I have 1 pi over 3 and 2 pi over 3. 2 pi over 3, I drop down. Okay, again, I divided by 3, so I know it's a 30, 60, 90. I just have to determine which one's my long side and which one's my short side. If I look at my two angles here, based off my picture, it's kind of hard to tell. So we have to look and see if this is going to be like 30 or 60. We took this straight angle right here, that's 180 degrees, and split it 3 ways, which means this is a 60 degrees. So this is going to be my long side. And this is my short side. Opposite 60 is my square root of 3. My longer side, opposite 30 is my shorter side. It's a half. So tangent, again, the coordinates of this point, my x is negative in the second quadrant because I went left. My y is positive, square root of 3 over 2. We have sine over cosine, or y over x. Square root of 3 over 2 divided by negative 1/2. Again, I multiply by the reciprocal to get rid of my division. Here, my 2's cancel. I end up with just negative square root of 3. And that's what tangent of 2 pi over 3 equals. Negative square root of 3. Now we have negative pi over 4. I'm just going to start a new circle here. One, 2, 3. I'm going to try that one again. 3, 4. Not perfect, but close enough. Negative pi over 4 is here. 45, 45, 90. So these are both square root of 2 over 2. Negative square root of 2 over 2. So y is negative square root of 2 over 2 over square root of 2 over 2. Anything divided by itself is 1. So I end up with just negative 1.